Question 1. 1.64 minus 0.4. We want to line up our decimal points, setting our work out clearly. So I'd write it out like that and make sure my decimal points all line up, because the decimal point in my answer is going to be underneath those decimal points. I like to look to add extra zeros so the number of digits in each of the numbers matches. So I'm going to add a 0 to the 4 there to make it the same sort of number of decimal places as the 1.64. Just helps your brain, helps your working, make sure you get everything lined up properly. The decimal point in my answer stays in line. We'll see that happening. So let's have a look. We'll subtract now. 4 minus 0 equals 4. 6 minus 4 equals 2. Here's where we'll remember to put our decimal points straight underneath the decimal points from the question. And then 1 minus 0 gives us 1 there. So our final answer, when we do everything clearly and lining everything up properly, 1.24. Question 2. Solve 2y plus 16 equals 6y minus 4. We move all the numbers away from the letter until the letter's on its own. We move numbers by doing the opposite operation to both sides. And we usually move plus or minus numbers before we move multiply or divide numbers. This question has letters on both sides, so to solve an equation with letters on both sides, let's combine the letter terms first by moving the smaller letter term first. The question goes much more smoothly when we do that. So let's look to the smaller letter term. We have two letter terms there, 2y and 6y. So let's look to move the 2y first here. Now the 2y is a positive 2y, so when we want to move that, we'll minus both sides the 2y. On the left hand side that'll cancel out and leave us just with 16. On the right hand side we'll process 6y minus 2y makes 4y, and we'll have a minus 4 after it. Now we'll just solve normally. We want to get numbers away from the letter side there. We'll act on plus or minus numbers, act to undo plus or minus numbers before we act to undo any multiply or divide numbers. So let's move on the minus 4. To move a minus 4 we do the opposite, which is plus 4 both sides. On the left hand side that becomes 20. The right hand side, the minus 4 and the plus 4 will cancel out, leaving us with just the 4y. We're looking to get the y totally on its own. The 4 is multiplying by that y, so we'll need to divide by 4 both sides to get the letter on its own. On the right hand side the y will be on its own, and on the left hand side we'll get 5 when 20 is divided by 4. That can be just switched around, and so the y ends up being equal to 5 to solve that equation. Question 3. 13 over 20 converted to a decimal is 13.0, 20.13, 0.13 or 0.65. We'll divide the bottom into the top, which happens in a fraction. So the top is 13, which we'll write out as 13.000. We can put as many zeros as we like after that. And we'll just divide 20 in. This is an old school short division here, but this is how you do it if you didn't have a calculator handy. So anyway, so 20 divides into 13, not really. So we'd have to put a 0 there, and the decimal point goes directly above where it is in the question. And then we've actually got to carry over the 1 and the 3 because we haven't done any dividing yet as such. So 20 into 130, 20 goes 6 times into 120, and we'll get 10 left over there. We'll get a remainder of 10. So 6 lots of 20 makes 120. We'll have a 10 remainder, which will move over to the next 0. And we'll say 20 into 100. goes 5 times. Exactly, so no remainder there. So we've established that 20 divided into 13, which is effectively what's happening when you've got a fraction of 13 over 20, that goes in 0.65 times. There are other ways to do this, but this is the way I'm doing it today. So we get D as our final answer there. Question 4. Simplify, writing your answer as a whole number, 10k to the 0. Any item that has a power of 0, that item equals 1. Here we've got 10 lots of something to the 0. That 10 isn't being put to the power of 0, but we have 10 times something that's 1. That k to the 0 equals 1. So 10 lots of 1 is 10. Question 5. Find the surface area of this cylinder. We've got a height of 13 meters and it looks like a radius of 8 meters. This is a formula question, so we'll look to write our formula out on the top line. Underneath that, on the second line, we'll substitute all the numbers in from the question, then calculate our answer from that, and double check our units to make sure we're using the appropriate units in our final answer. So the formula for this one, and formula for the surface area of a cylinder, I'm here to tell you 2 pi r squared plus 2 pi r h. So we have a radius, an r of 8, and a height or an h of 13. So on the second line we're going to substitute those in. 2 lots of pi lots of 8 squared for the first section, plus 2 lots of pi lots of 8 lots of 13, when our r of 8 and our height of 13 go in the right places there. So we'll type that all carefully into our calculator and we will get a surface area of 1055.58 if we round that off to 2 decimal places. Now the question didn't specify how many decimal places it wanted. I just then am allowed to decide how many decimal places I round off to. And it's polite to tell the marker what you've done. So if I've rounded off to 2 decimal places, I'll put that to 2 decimal places or to 2 dp after my answer. Now you could have left it as a whole number. If you did, you would have rounded it off to 1056 because 5 or more raise the score. If you rounded yours off to 1 decimal place, that's fine. You would have got 1055.6 if you rounded it carefully. So it's up to you if they don't tell you. Matter of fact, there's some argument to say that if you're only using whole numbers for your meters originally, you shouldn't have your final answer any more specific than that, than any more rounded off to more decimal places than whole numbers. But anyway, that's a debate for another day. Question 6. Express 18 marks out of 20, pretty good mark, as a percentage. So let's write this mark as a fraction. We've got 18 out of 20 in our test. I'd be showing Mum or Dad it pretty proudly there. Okay, and to turn that into a percentage, multiply the fraction by 100. So we can multiply across the top and across the bottom, or we can actually divide the bottom by 20 and the top by 20 if we divide the 20 into the 100. Anyway, we can simplify it a number of different ways, but we end up with 90% there. Question 7. Find the value of x if x squared equals 15 squared plus 36 squared. Looks like something that's come from a Pythagoras question. Well, let's see what we've got. Let's simplify here. 15 squared is 225. 36 times 36 apparently is 1296. Those two can be added together to give us x squared equals 1521. Now to get x on its own, which the question asks for, we'll need to undo a square, which we'll need a square root to do that. got to do it to both sides. On the left hand side that leaves us with x, and on the right hand side we have square root of 1521. If we type that through our calculator, we get x value, and x value finally of 39. Question 8. Expand and simplify 8 outside of 3 plus 5a plus 7a. To expand an expression, multiply the front term by each of the terms inside the brackets. So we want to multiply the 8 by the 3, get an answer. 8 by the 5a, get a separate answer, keep them apart. And that will expand our brackets. So 8 lots of 3 is 24. Now 8 lots of 5a is plus 40a. Keep them separate because they're not like terms. And we just have plus 7a, which wasn't affected by the expanding of the brackets. We're then allowed to add and subtract like terms. Can you see that there's two like terms there? The 40a and the 7a have the same letter and power, so they can be merged together. We've got 24 that needs to stay separate, that's just a normal number, and we get 47a in total. So that's our final expression out of that expansion and simplification there. 24 plus 47a. Question 9. The value of c in the diagram below is 55 degrees, 65 degrees, 70 degrees, or 180 degrees. Adjacent angles that make up a straight angle add up to 180 degrees. We've got 3 adjacent angles there that are all sitting on a straight line, so we know they add up to 180 degrees. So we'll do some calculation that looks a bit like this. We could take 180 degrees and subtract from that the total of the two other angles, 55 and 55. You could alternately do 180 minus 55 minus another 55. Works out to be the same thing. So that leaves us with what the value of c is, which is 70 degrees. So that's option C there, 70 degrees. Question 10. If a set of scores has a mean of 16 and a sum total of 192, how many scores are there? Okay, this is our mean set up. To find the mean, usually we have a sum of scores, a sum total of scores, and it's divided by the number of scores to find our mean. In this question, if you look carefully though, we're given our mean and our sum total, and we've got to work backwards to find out the number of scores. So what we can do, one approach is to rearrange our original equation here so that the number of scores, how many scores there are, is out the front. So we're allowed to swap places with those two things. You might see this in trigonometry at times. We're allowed to swap places where the mean is and the number of scores, those can swap. So we end up with a rearranged equation here of the number of scores will equal the sum of the scores on top divided by whatever the mean is. That's going to be more useful in our case here. So we've got the number of scores is equal to the sum of the scores. In the question we're told that they've got a sum total of 192, and we're also told in the question that the mean was 16. So let's put them in the right places there, and we get a final answer of 12 scores. Now there are other ways of doing that. You could use the original equation there, put the 192 on the top and the 16 on the left hand side and rearrange after that point, but that's the way I chose to do it today.